This session is going to introduce you to the topic of arithmetic progressions. Arithmetic progression is basically a sequence of number. So let us define what an arithmetic progression is. So arithmetic progression is a sequence of numbers where any two consecutive terms differ by the same quantity. So let me explain this in more detail. But before we understand what arithmetic progression is, let us first understand what is meant by sequence of numbers. So a sequence of numbers is basically a collection of numbers. Where there is a certain relation to generate the numbers. Okay, so let me give you some examples. Let us define the symbol UN or AN or TN, right? You could define either of these. Let us define AN as my nth term in the sequence. Okay, so for example, if I write the sequence 1, 4, 9, 16, 25, 36, 49, then over here 1 is my A1, 4 is my A2, 9 is my A3, 16 is my A4, 25 is my A5, and 36 is A6, 49 is A7. So you will notice that the subscript that I write over here, this basically represents the position of that particular term. So for example, here A6 implies that it is the 6th term. A7 implies that it is the 7th term in the sequence, right? Now this is a sequence, right? This is a sequence of numbers where I can say that the formula for generating the nth term is basically the square of that particular position. For example, if I take A1, if I want to find A1, that means instead of n, I am basically substituting a 1. So A1 is basically going to be 1 square, which is basically 1. If I want to find A2, then A2 is going to be, instead of n, I am substituting 2. So A2 is going to be 2 square, which is 4. And this is how I generate the terms of this particular sequence. So this particular sequence has a general term. This is called the general term of this particular sequence, right? So basically this is the term, this is the formula that helps you generate any term of this particular sequence. So this collection of numbers, which is governed by the formula n square, is called a sequence of numbers. And the formula that helps you generate any term of that sequence is called the general term of that sequence. So this is the general term, while this is the sequence, while this whole collection of numbers is the sequence that you generate, right? Now there I could take up some more examples for showing you the concept of sequence and the terms. So let us consider the following general terms. An is n cube. Now please remember that n can only be a natural number. It cannot even be a whole number. So n cannot take a value of 0. N will always belong to natural numbers. So when I say I want to find a1, it means instead of n I am substituting 1. So a1 is 1 cube, that is 1, which means that a1 is nothing but this is the first term. So therefore the first term is 1. Let's find a2. So a2 is going to be 2 cube. Instead of n I am substituting 2. So 2 cube is equal to 8. That means that this is the second term. Then let's find a3. So for a3 we can substitute n as 3. So this becomes 3 cube. 3 cube is 27. So this is my third term and so on. So the sequence is basically going to be 1, 8, 27, the next term is going to be 4 cube, which is 64, and then 5 cube is 125 and so on. So this is my sequence. I have represented it with multiple dots towards the end to show that the sequence continues. 1 is my first term, that's a1. 27 is my third term, that's a3. 64 is my fourth term, that is a4, right? So this is the formula for generating the nth term of the sequence. That is why this particular formula is called the general term. This is the general term. And this set of numbers is basically my sequence. Let's consider the second example now. The formula given is an is 5n square plus 2. So if I want to find the first term, I will substitute n as 1. When I substitute n as 1, I get a1 is equal to 5 into 1 square plus 2, which is equal to 7. I can substitute n as 2 and I will get my second term. So I'm substituting n as 2. So this becomes a2 equals 5 into 2 square plus 2, that is 5 4s are 20 plus 2 is 22. When I substitute n equals 3, a3 becomes 5 into 3 square plus 2. Now 3 square is 9 5s are 45 plus 2 is 47. If I substitute n as 4, then a4 is the fourth term, that becomes 5 into 4 square plus 2. Now 4 square is 16, 16 5s are 80, 80 plus 2 is 82, and I can keep doing this for all value for more values of n. And therefore my sequence is, the first term is 7, then I have 22, then I have 47, and then I have 82 and dot dot dot. So basically this is the general term of this particular sequence. I can say that this is one formula that helps me generate any term of this sequence, and the actual sequence is shown over here. It is 7, 22, 47, 82 and so on. So 7 is my first term and 22 is the second term and so on. So now let's take a look at this particular sequence, the third example. An is 3n plus 2. So let us go ahead and find the different terms. So a1 is going to be 3 into 1 plus 2, that's 5. a2 is going to be 3 into 2 plus 2, that's 6 plus 2 is 8. a3 is going to be 3 into 3 plus 2, that's 9 plus 2 is 11. a4 is going to be 3 into 4 plus 2, that's 12 plus 2, that is 14. And therefore the sequence generated is, the sequence of numbers is 5, 8, 11, 14, dot 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 dot. So again, this was the general term to generate the terms of this particular sequence, and the actual sequence is as shown over here. So it is 5, 8, 11, 14 and so on. Now there is something that's very peculiar about the third example. Look at the terms of the sequence. You will notice that the consecutive terms differ by a value of 3. For example, the difference between 5 and 8 is 3. The difference between 8 and 11 is also 3. The difference between 11 and 14 is also 3. So you will notice that the difference between any consecutive terms, the difference between any two consecutive terms is a constant, right? And that is why this particular sequence of numbers is called an arithmetic progression. In case of the first two examples, the difference is not remaining constant. 8 minus 1 is 7. In the first sequence, let's take a look at the difference. 8 minus 1 is 7. 27 minus 8 is 19. And 64 minus 27 is 37 and so on. The difference doesn't remain a constant. Even in case of the second sequence, you will notice that the difference was 15 between the first two terms and the difference between the next two terms was 25 and so on. So the difference is definitely changing in case of the first two sequences. But in case of the third sequence, the difference between any two consecutive terms is always remaining a constant. And that is why such a sequence is known as arithmetic progression. So let me pause for a minute before I continue with my next part. So let us consider the following general terms. Let us find out the different terms of these sequences and then let's determine whether it's an AP or not. So the first general term is an is 5n minus 8. Okay, let's substitute n as 1. This will give me my first term. So a1, I'm substituting n as 1. So this becomes a1 is 5 times 1 minus 8, which is 5 minus 8 is minus 3. Let's substitute n as 2. A2 becomes 5 times 2 minus 8. That is 10 minus 8. 10 minus 8 is 2. Let's find the third term. That's n equals 3. So A3 becomes 5 into 3 minus 8. That's 15 minus 8. And 15 minus 8 happens to be 7. Let's find n equal to 4. So A4 will therefore be 5 into 4 minus 8. That is 20 minus 8, which equals 12. So if you take a look at the terms, you have minus 3 is the first term, 2 is the second term, 7 is the third term, 12 is the fourth term, and if I find the fifth term, if I find 25 minus 8 is going to be 17, and this continues. So let's determine whether this is an AP or not. You will notice that the difference between the first two terms is 5. So 2 minus of minus 3 is 5. The difference between the third term and the second term is also 5. 12 minus 7 is also 5. and 17 minus 12 is also 5. So you will notice that this difference remains constant, which is equal to 5, and hence I can say that this sequence is an AP. Similarly, let us try finding the terms of this sequence. Let's take n equals 1. So when n equals 1, t1 is 1 square minus 2. That is 1 minus 2 is minus 1. Let's take n equal to 2. N equal to 2 is basically t2 is 2 square minus 2. That is 2. Let's take n equal to 3. T3 is going to be 3 square minus 2. That's 9 minus 2 is 7. If I take n equal to 4, then T4 is going to be 4 square minus 2. 16 minus 2 is 14. If I take n equals 5, T5 is going to be 5 square minus 2. That is 23, right? So the terms of the sequence are minus 1, 2, 7, 14 and 23, ... Now if you determine the differences, you will note that the differences are not constant. Therefore, this is a sequence. Definitely it is a sequence, but it does not qualify as an arithmetic progression. Whereas the first sequence that we had, it qualified as an arithmetic progression. Let us now similarly try the third one. So let us substitute n as 1. If you substitute n as 1, you get t1 is 1 plus 1 by 1, 1 plus 1 by 1, which is 2. If you substitute n as 2, t2 becomes 2 plus 1 divided by 2, that is equal to 3 by 2. If you substitute n as 3, then t3 becomes 3 plus 1 by 3, that is basically 4 by 3. If you substitute n as 4, t4 becomes 4 plus 1 by 4, which is basically 5 by 4. So the terms of the sequence are 2, 3 by 2, 4 by 3, 5 by 4 and so on. Again, you will notice that the difference between any two consecutive terms does not remain constant. For example, difference between 2 and 3 by 2 is negative half. Again, please note that I am always finding the second term minus the first term. So the difference is always taken of the next term minus the current term, right? And the difference between 3 by 2 and 4 by 3 is definitely not minus half. And that is why this does not qualify as an AP. So I hope from these examples you understood the meaning of TN or AN and how do you determine whether a sequence is AP or not. Pausing for a minute for you to take a look at all these questions. Okay, let us now take some more examples of sequences. So let's consider the following three sequences. Let's find the first four terms of all these sequences. So to find the first four terms, I will now have to find A1. So A1 will therefore be 1 cube plus 1 square. That is 1 plus 1, which equals 2. Then A2 will be the second term. That will be 2 cube plus 2 square. That is 8 plus 4. 8 plus 4 is 12. A3 is going to be 3 cube plus 3 square, that is 27 plus 9. 27 plus 9 is 36. A4 will be 4 cube plus 4 square, that is 64 plus 16, which equals 80. So therefore the sequence is, first term is 2, the next term is 12, the third term is 36, and then you have 80, and this goes on. You will notice that the difference between the two terms is not constant, therefore it is not an AP, right? This is not an AP. Let us now find the value for the first four terms of the given expression. So A1 will be 1 into 1 minus 1 into 1 minus 2. A2 will be 2 into 2 minus 1 into 2 minus 2. A3 is going to be 3 into 3 minus 1 into 3 minus 2. A4 will be 4 into 4 minus 1 into 4 minus 2, right? So A1 will therefore be 0, A2 will also be 0, A3 will be 3 2s are 6, 6 1s are 6, and A4 will be 4 into 3 is 12, 12 2s are 24. So therefore the sequence here is 0, 0, 6, 24. And again here you will notice that the difference between two consecutive terms is not constant, and hence this is not an AP, right? Now let's take the third example where an is 10 minus 5n. So let's find the first four terms, A1, A2, A3 and A4. A1 is going to be 10 minus 5. A2 is going to be 10 minus 5 into 2. A3 is 10 minus 5 into 3 and A4 is 10 minus 5 into 4. Now 10 minus 5 is 5 and 10 minus 10 is 0. 10 minus 15 is minus 5 and 10 minus 20 is minus 10. Therefore, I can say that the sequence is 5, 0, negative 5, negative 10. This is the sequence of numbers, right? So you will notice that the difference between two consecutive terms is constant here, and hence I can say that this is an AP, right? The difference between two consecutive terms here is minus 5, if you notice. So this is the idea behind how to generate a sequence, what are sequences and what are the different terms of the sequence, what is the meaning of general term of a sequence, and how do we identify an AP. So this is what we have discussed so far. So now we are going to turn our attention towards understanding the different terminologies in an arithmetic progression. I will pause for a minute before proceeding. Okay, now let us consider an AP. Any multiplication table you must have noticed will form an AP. So let's take 0, 7, 14, 21, 28, 35, 42 and so on. So this is a sequence of numbers, and this also forms an arithmetic progression because the difference between any two consecutive terms is constant. So the first term that you notice in the arithmetic progression, this is called the first term. This is the first term which is represented by the letter A. Okay. The difference, let us now write. So the first term is T1, or somebody can also write it as A1. The second term is T2, or you can also write it as A2. By the way, the first term could also just be written as A. The third term is written as T3, or it is basically A3. 21 is the fourth term, that's T4 and also written as A4. 28 is the fifth term, so that's T5, which can also be written as A5. So you will notice that 42 is the seventh term, and of course there will be many more terms beyond this point. So the first term of an AP, is denoted by the letter A. The difference between any two consecutive terms is a constant. So you will notice that T2 minus T1 is 7 minus 0, which is 7. T3 minus T2 is 14 minus 7, which happens to be 7 again. T4 minus T3 is 21 minus 14, which is also 7. So therefore, the difference between the n plus 1th term and the nth term, this difference is called the common difference, right? And common difference is represented by the letter D. So let's understand what is Tn plus 1 and Tn. So Tn means the nth term of the AP, the nth term of the AP. For example, if n is equal to 5, then T5 would be the fifth term of the AP, right? Whereas if you substitute this 5, if you replace this 5 by 3, then this would be T3 would be the third term of this particular AP, and so on. So Tn basically represents the nth term in that particular sequence, and therefore Tn plus 1 will represent the n plus 1th term in that sequence, right? So basically n plus 1th term is going to be the next term. So if I keep writing the AP, it will be T1, then there's T2, there would be the third term, there would be the fourth term, and this keeps going on till the nth term. And the term beyond that is going to be Tn plus 1. This is the n plus 1th term of this particular AP, right? And the difference between the n plus 1th term and the nth term, this difference is called the common difference, which is represented by the letter D. So for example, D can be calculated as T8 minus T7, the next term minus the current term. Or D can also be calculated as the 100th term minus the 99th term. Or it can also be calculated as the 46th term minus the 45th term. This is how you can calculate D in any given question, right? It is basically the next term minus the current term. So these are two important terminologies in case of AP. First is the common difference is represented by the letter A, and the first term is represented by the letter A, and the common difference is denoted by the letter D. So if you have understood this, then we are going to go ahead and we are going to derive some more terms that are related to arithmetic progressions. So again, pause it for a minute here before continuing. Okay, so now let us understand some more important terms in AP. So we know that the first term is represented by the letter A and the common difference is represented by the letter D. So now I know that the first term is A. Now I want to find, is there a way that I can find the second term? So I know that common difference is given by the second term minus the first term. Therefore, D is equal to second term minus the first term is A, right? Now this negative A transposes to the other side and it becomes A plus D is equal to the second term. That means the second term here is A plus D, right? Now I can go ahead and find the third term. So let's see how to do that. I know that the common difference is also given by the third term minus the second term. This is the definition of the common difference. And therefore, D plus the second term is going to be my third term, which implies that I can, the second term is A plus D. So this becomes D plus A plus D is equal to T3. And therefore, the third term is given by A plus 2 times D. So this is A plus 2D. Not difficult to guess what the fourth term should be. You will notice that in each of the terms, I am adding D basically. So when I add D to A, it becomes A plus D. In A plus D, if I add a D, it becomes A plus 2D and so on. It continues like this, right? So now I am going to find the fourth term. I know that the common difference is given by fourth term minus the third term. The third term can come to the left hand side for addition. So T3 plus D is therefore equal to T4. The third term is given by A plus 2D and then there is a plus D is equal to the fourth term, which means A plus 3D is equal to T4. That means the fourth term of the arithmetic progression is A plus 3D. Not difficult to guess what the next term should be. So now I can say that I see that the coefficient of D is continuously increasing by 1 and therefore the next term has to be A plus 4D. So let us take a look at this whole procedure one more time. We know that the common difference was the second term minus the first term. The first term was the letter A, right? It was represented by the symbol A and negative A transposed to the other side as positive A. Therefore, A plus D was equal to T2. So the second term was therefore equal to A plus D. What it meant is the first term was A and the second term is A plus D. So it means that I have added common difference to the first term to get my second term. Similarly, common difference was also defined as the third term minus the second term. And the second term is in subtraction on the right hand side. It transposes to the left hand side as addition. And therefore, D plus T2 becomes equal to T3. Now I can substitute the value of T2. T2 is the second term which can be substituted as A plus D. And therefore D plus A plus D becomes the third term and therefore T3 becomes A plus 2D. Right? This is the third term. So again to the second term, when I add a D, I get the third term. And therefore the logic tells me that if you keep adding D to every term, you are always bound to get the next term, right? So if the third term is A plus 2D, then the fourth term should be A plus 3D. So how can I derive that? I know that the common difference D is equal to T4 minus T3. The T3 is in subtraction. It transposes to the left hand side as addition. So T3 plus D becomes T4. Now T3 is the third term and third term is nothing but A plus 2D. So T3 can be substituted as A plus 2D. So A plus 2D plus D becomes T4, which means T4 becomes A plus 3D. So the fourth term becomes A plus 3D, and that's why again in the fourth term you can again add a D and you will get the fifth term and so on. Therefore, I can say that the first term was A, simply A, or I can also write it as A plus 0D. The second term was A plus 1D. A plus 1D. The third term is A plus 2 times D. The fourth term was A plus 3 times D. The fifth term was A plus 4 times D, and so on. So is it possible to guess what is the 90th term of this particular AP? So if I want to guess this particular term, I will start taking a close look at any pattern that is hidden in the first 5 terms. I'll give you a minute to think about the pattern and then I will give you the answer. So I definitely see a pattern. I notice here that whatever is the index of the term, the coefficient of D is 1 less than that. So if I'm finding the first term, then the coefficient of D is 1 less than 1, which is 0. If you notice, A remains the same everywhere. The only thing that changes is the coefficient of D, and the coefficient of D is always 1 less than the index, which means the 90th term is bound to be A plus 89D. The coefficient of D is 1 less than the index, right? And therefore, I can say that the 41st term will be A plus 40 times D. The 39th term will be A plus 38D. The 500th term is going to be A plus 499D. The index is basically reduced by 1 to get the coefficient of D. And therefore, I can say that the nth term of this particular AP is going to be A plus n minus 1 times D. The coefficient of D is the value of n reduced by 1. And that is what is happening in all these examples, if you notice, right? This particular formula, which helps me derive any particular term in the AP, is called the general term of the AP, right? So this formula for Tn is called the general term of the given AP. Pausing for a couple of seconds for you to take a look at all this and then we will move on. Okay, let us now take some examples. So let's consider that Tn is 3 plus 2n. The first question is, can you show that it is an AP? So if I want to show that a given sequence is AP, I want to show that, so to show that it is an AP, I would like to show that the difference between the n plus 1th term and the nth term is a constant, right? This is what I have to show. So the difference between any two terms, any two consecutive terms should be shown as a constant. So it is given to me that Tn is 3 plus 2n. So if I want to find Tn plus 1, that is, I'm substituting the value of n by n plus 1, if you notice, right? That means I'll have to do that even over here. I'll have to substitute this n as n plus 1. So this becomes 3 plus 2 times n plus 1, and that is equal to 3 plus 2n plus 2, which is equal to 5 plus 2n. So my n plus 1th term is 5 plus 2n, and my nth term is 3 plus 2n. So now I can find the difference. So Tn plus 1 minus Tn, this is the difference between any two consecutive terms, is going to be 5 plus 2n minus of 3 plus 2n. Therefore, this becomes 5 minus 3 plus 2n minus 2n. Now 2n minus 2n cancels and 5 minus 3 is 2. So as the difference between n plus 1th term and nth term is a constant, which is 2, therefore it forms an AP. Now, can you find the first term? Of course I can. So Tn is 3 plus 2n. If I want to find the first term, I'll have to, so to find the first term, T1, I will simply substitute n as 1. Right? Substitute n as 1. Therefore, T1 becomes 3 plus 2 times 1, which is equal to 3 plus 2 is 5. So the first term is therefore equal to 5. Can you find the common difference? Of course, the common difference has already been found. Common difference is nothing but the difference between the n plus 1th term and the nth term. And that was already found out in the previous, one of the previous subparts. So we found that Tn plus 1 minus Tn was 2, and therefore the common difference is 2. Can you find the general term? Well, I have already been given the general term. The general term given to me is 3 plus 2n, and therefore the general term is 3 plus 2n. So general term is basically that general formula which helps me derive any particular term in the given arithmetic progression, right? So again, let me pause for a minute before I move on to the next question. Moving on to the next example. So let's consider the following question. Consider the given sequence. So the sequence is 3, 7, 11, 15, 19. You have to find the first term. So first term is definitely going to be 3. Then we have to find the third term. So the third term, so 3 is the first term, 7 is the second term, and 11 is the third term. So the third term is 11. Show that it is an AP. So let me find the second term minus the first term. Second term minus first term is 7 minus 3, which equals 4. Let me find the difference between the third term and the second term, which is 11 minus 7, which is also 4. Let me find the difference between the fourth term and the third term, which is 15 minus 11, which is also 4. Let me find the difference between the fifth term and the fourth term, which is 19 minus 15, which is also equal to 4. So since the difference since the difference between any two consecutive terms is a constant, I can say that it is an arithmetic progression, right? And what is the common difference? The common difference is 4 in this case. So I can say that this AP has A equal to 3 and the common difference is equal to 4. These are two very important parameters of any arithmetic progression. Now I have to show that it is an AP. I have already shown that it is an AP. Find the general term. So general term Tn is given by a plus n minus 1 times d. Now I know the value of a, I know the value of d, so let me substitute it. A is equal to 3 and d is equal to 4. So this becomes 3 plus 4n minus 4, which is equal to 4n minus 1, right? And therefore the general term Tn is given by 4n minus 1. This is called the general term of the given arithmetic progression. Now I have to find the 100th term. So one option is I can keep on writing terms till I reach the 100th position. But that's a pretty long affair. Then why are we learning this topic in the first place? So because we have understood that Tn is 4n minus 1, I can now easily find the 100th term. So 100th term can be found out by substituting n as 100. So this becomes 4 times 100 minus 1, which is 400 minus 1, which is 399. So the 100th term is therefore going to be 399. This is how I can find the 100th term. So this is the power of the general term, that it was able to give me the 100th term without me having to write all the terms in the given arithmetic progression. This is the strength of this particular idea of the general term, right? So this is how I solve a question that's related to AP. Let me again pause for a minute before moving on to the next question. Let us take one more example. Let us consider the following question. Consider the sequence Tn is 5n plus 11. So the general term is already given to me. The general term is Tn is 5n plus 11. I want to find the first term. So to find the first term, I am simply going to substitute n as 1. I am going to substitute n equal to 1. So if n is equal to 1, then T1 is going to be 5 times 1 plus 11. That is equal to 5 plus 11 is 16. So the first term is therefore 16. Let us now find the common difference. So to find the common difference, I know that I can find the common difference d as the difference between the n plus 1th term and the nth term. So what is the nth term? Let us now find the n plus 1th term. I know that the nth term is 5n plus 11, and therefore the n plus 1th term is basically, let me substitute n by n plus 1. So this becomes 5 times n plus 1 plus 11, which is 5n plus 5 plus 11, and this is equal to 5n plus 16, right? So the n plus 1th term is 5n plus 16 minus the nth term is 5n plus 11, right? And if you now evaluate this, this would be 5n plus 16 minus 5n minus 11. 5n minus 5n cancels. 16 minus 11 equals 5. And therefore, as the difference is constant, this is definitely an AP, right? And this common difference happens to be 5. So the first term was 16. The common difference is now 5. I need to find the 15th term. So I know that Tn is equal to 5n plus 11. So to find T15, which is the 15th term, I will have to substitute n as 15. So this becomes 5 times 15 plus 11, which is 75 plus 11 is equal to 86. This is my 15th term, right? So this is the power of the general term. It helps me find any term that I want in the AP. Now let's take a look at the D subpart. Which term is 196? That means there is some term in this AP which equals 196. So the nth term is equal to 196. I want to find which term, that is, I want to find what is the value of n. N represents the position of a particular term, right? So I want to find the position of this particular term, which means Tn is 196. This is the nth term. And therefore, I have to find n. So Tn is 5n plus 11 is 196, which means 5n is equal to 185, and therefore n is equal to 37, which means that the 37th term of this particular arithmetic progression is going to be 196. So this is how I solve this particular problem. I am going to pause for a minute, take a look at the solution, and we end our today's session on arithmetic progressions over here. We will take up many more problems in the next session.